Geometry. Good to see you guys. I'm out here in the shop making a little table, but let's do some math, okay? Okay, we're going to do section 3 of chapter 8, and it's called Special Right Triangles. Everybody likes to be special. You guys are special. You ride the special bus to school? No, just kidding. So there's two in particular that we're going to talk about. The first one, think about a square. You know that a square has four 90-degree angles. It's got four sides that are all the same. And let's say that we go from vertex to vertex and we cut this into, well, let's just worry about one triangle. So get rid of all this. And you can see now that this is going to be half of 90, which is 45 degrees. This is going to be half of 90, which is 45. And that's 90, okay? So let's talk about this hypotenuse here. First of all, you can see that anytime there's a 45, 45, 90, that had to come from a square, so you know that the sides are always going to be the same. The legs of the triangle going to be the same. Now, according to the Pythagorean theorem, s squared plus s squared equals h squared, right? A squared plus b squared equals c squared. So you get 2s squared equals h squared. If you want to find out what the hypotenuse is, you got to take the square root of that side and the square root of this side. Okay? And I'm about running off the page. The square root of 2s squared, well, the square root of s squared is just going to be s. The square root of 2 is going to be just the square root of 2. We'll just leave it like that. And the square root of h squared is h. Okay? So you end up finding out, and this is theorem 8.8. It says that in a 45, 45, 90 triangle, the legs of the triangle are going to be the same, and the hypotenuse is always going to be the square root of 2 times one of those legs. So that's that, okay? That's theorem 8.8. Let's talk about another special triangle. And this one, it's easiest probably if we start off with an equilateral triangle. Okay? Ooh, not a good equilateral triangle. But you know that this would be 60 degrees, and 60 degrees. And at this point, I can hear what you're saying to me. You're saying, Mr. Ritchie, you're losing your mind because that is not a right triangle. And I said, we're going to talk about special right triangles. Well, hold on. Cool your jets. Let's do the altitude here. The altitude for an equilateral triangle is going to bisect that angle. And so let's just worry about, let's get rid of this whole side. But it's going to bisect that, so what degrees is that going to be? That is now going to be 30 degrees. So this triangle is going to be a 30, 60, 90 triangle. That's our second special right triangle. If we gave this some measurements, actually, you know what? I am going to leave this on here for a second just to show you. So let's call this distance here, from here to here, we're going to call that x. And so, of course, since this is bisecting everything, this and this is going to be x also. Therefore, you know that this leg is going to be 2x. And this would be 2x also. Okay, now I think we can get rid of this. All right. So, using the Pythagorean theorem, this leg squared plus this leg squared. Oh, no. Sorry, that's not a leg. That's a hypotenuse. This leg squared plus this leg squared equals the hypotenuse squared. Okay? So let's do a little algebra. 2x squared, or 2x, the whole thing squared, you know is going to be 4x squared, right? And we have a squared, and we have this x squared. Take away x squared from this side and from this side. And you're left with a squared equals 3x squared. Now, take the square root of this and the square root of this. And just like before, you end up with the altitude, oops, not the altitude squared, the altitude equals the square root of 3, and the square root of that is just going to be x itself. Okay? So, this is, sorry, it's on the next page. This is theorem 8.9, and it says that in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the shorter leg. And you can see that here. Here's our shorter leg. This hypotenuse is going to be twice as long as that shorter leg. And what's the relationship here? The relationship is the longer leg is going to be square root of 3 times the shorter leg. Okay? All right. I think that's all there is. That was fun. Go back to doing what you're doing, and I'm going to go back to finishing my table.